Messier 82, also known as NGC 3034, Cigar Galaxy or M82 is a starburst galaxy approximately 12 million light-years away in the constellation Ursa Major. It is the second largest member of the M81 group, with the D25 isophodal diameter of 12.52 kiloparsecs. It's about 5 times more luminous than the Milky Way, and its central region is about 100 times more luminous. The starburst activity is thought to have been triggered by interaction with neighboring galaxy M81. As one of the closest starburst galaxies to Earth, M82 is the prototypical example of this galaxy type. In 2014, in studying M82, scientists discovered the brightest pulsar yet known, designated M82, X2. M82, with M81, was discovered by Johann Alert Bode in 1774. He described it as a nebulous patch, this one about 3/4 degree away from the other, very pale and of elongated shape. In 1779, Pierre Méchain independently rediscovered both objects and reported them to Charles Messier, who added them to his catalogue. M82 was believed to be an irregular galaxy. In 2005, however, 2 symmetric spiral arms were discovered in near-infrared images of M82. The arms were detected by subtracting an axisymmetric exponential disk from the NIR images. Even though the arms were detected in NIR images, they are bluer than the disk. The arms had been missed due to M82's high disk surface brightness, the nearly edge-on view of this galaxy, and obscuration by a complex network of dusty filaments in its optical images. These arms emanate from the ends of the NIR bar and can be followed for the length of 3 disk scales. Assuming that the northern part of M82 is nearer to us, as most of the literature does, the observed sense of rotation implies trailing arms. In 2005, the Hubble Space Telescope revealed 197 young massive clusters in the starburst core. The average mass of these clusters is around 200,000 solar masses, hence the starburst core is a very energetic and high-density environment. Throughout the galaxy's center, young stars are being born 10 times faster than they are inside the entire Milky Way galaxy. The Chandra X-ray Observatory detected fluctuating X-ray emissions about 600 light-years from the center of M82. Astronomers have postulated that this comes from the first known intermediate mass black hole, of roughly 200 to 5,000 solar masses. M82, like most galaxies, hosts a supermassive black hole at its center. This one has mass of approximately 3 times 107 solar masses, as measured from stellar dynamics. In April 2010, radio astronomers reported an object in M82 that had started sending out radio waves, and whose emission did not look like anything seen anywhere in the universe before. There have been several theories about the nature of this object, but currently no theory entirely fits the observed data. M82 is being physically affected by its larger neighbor, the spiral M81. Tidal forces caused by gravity have deformed M82, a process that started about 100 million years ago. This interaction has caused star formation to increase tenfold compared to normal galaxies. M82 has undergone at least one tidal encounter with M81, resulting in a large amount of gas being funneled into the galaxy's core over the last 200 million years. Stars in M82's disk seem to have been formed in a burst 500 million years ago, leaving its disk littered with hundreds of clusters with properties similar to globular clusters, and stopped 100 million years ago with no star formation taking place in this galaxy outside the central starburst and, at low levels since 1 billion years ago, on its halo. A suggestion to explain those features is that M82 was previously a low surface brightness galaxy where star formation was triggered due to interactions with its giant neighbor. As a starburst galaxy, Messier 82 is prone to frequent supernova, caused by the collapse of young, massive stars. The first supernova candidate reported was SN 1986d, initially believed to be a supernova inside the galaxy until it was found to be a variable short-wavelength infrared source instead. The first confirmed supernova recorded in the galaxy was SN 2004 AM, discovered in March 2004. It was later determined to be a Type II supernova. On January 21, 2014, a new supernova was observed in M82, at apparent magnitude plus 11.7, by astrophysics lecturer Steve Fossey and 4 of his students. It had brightened to magnitude plus 10.92 days later. The International Astronomical Union has designated it SN 2014J.